Then I would like to perform a series of heat-treated samples. Remember the possible difference between 46 degrees and 50 degrees. We should go up the whole scale and see how the reaction responds, say, in increments of 5 degrees. This will tell us a lot about chemistry and might separate chemistry from biology. We know nothing about the pH of the Mars soil when it's wet. We know a little something. There are some people who think it was acid, but I think the LR experiment indicates that it was really alkaline, that the second injection of Mars samples, which I did not show you, indicated that some of the radioactive material was being reabsorbed in the water, indicating that the water was alkaline in contact with the soil. So we'd like to know what that pH is. It will tell us a lot. When you deposit water on materials, there is either either exothermic or endothermic, depending on the reaction. We ought to determine that as we wet the samples. We should have a thermocouple in there. Then, I would like to add a variety of gases to the test chamber to determine its effect on the reaction. Some gases which are of metabolic interest, and similarly, I think I would like to add some metabolic poisons, and to study this sample in a controlled environment in many different ways to see, is it chemical, is it biological, and even a little more. If it is one or the other, can we begin to study the specificities of it? If it's chemistry, what kind of chemistry? If it's life, what kind of life? Getting ready to ask the paramount question of, is it life the same as we know it on Earth? Does it have the same kind of DNA? Is it made up the same way? Did we both come from some single source? Or, more interesting, are we different? Meaning that there are a tremendous diversity of species throughout the universe. Much more of an exciting finding. I'd be content with the former, however. Thank you very much.
Testing? Okay. If you run the LR experiment long enough, would another way of differentiating between a chemical and a biological effect be that the biological reaction would continue to increase, whereas the chemical would tend to level off because the organisms would reproduce and the rate would continue to increase?
Well, something becomes limiting at some point. And the question is, in the LR experiment, did the substrate become limiting, or was there an oxidant that was used up? And there's a lot of debate both ways on that.
Is there a way of defining an experiment that could resolve that, that could test that hypothesis either one way or the other?
We know that there was more radioactive material in the nutrient than came out. The radioactivity which evolved was more than the radioactivity contained, however, in one nutrient. So more than one nutrient was involved. We can't tell, however, whether that was limiting or whether the oxidant was. And there's, unless we measure the oxidant some way, perhaps by MOX, we can't really make an educated guess on that.
Yes. What about the possibility of flying a microscope to directly observe the samples while they're active?
Flying?
A microscope to look at what is going on to see if you can directly observe microorganisms in a sample that is...
A lot of effort was put in the Viking development phase into an automated microscope. trouble with the microscope is it doesn't really tell you very much. If you see a small spheroid, is it alive or not? You can't tell. And some people played games with moon sample dust, taking photomicrographs and saying, hey, is this alive or dead? And you really can't tell. And especially if you're going to look at an alien life, you wouldn't know what you were looking for anyway. So it'd be very difficult. Yes, Craig?
Dr. Levin, could you elaborate more on the poison you talked about? I know you talked about the pH and the endothermic or exothermic heat of reaction, but the poison would be an inert material which would not chemically react, so you could discount chemical reaction. Could you elaborate more on that so that we could determine once and for all whether that was life that you saw? What type of poison would you use? Would it be cyanide, or what type of poison are we talking about?
In the work, our early work with our experiment, we would take it out to, say, Death Valley. And at that time, it was called the sticky string experiment. It fell out on the sand, and a little bit of sand granules were pulled in, and then the nutrient was applied. We did not use heat as our control. In those days, we used an antimetabolite. We used an alcohol-based material. And this worked very, very well, and would be less likely to be susceptible to confusion, I believe. But I think we ought to do both in a future experiment.
Dr. Levin, we know that on Earth there are anaerobic microorganisms that do consider life to be a terrible poison, and that was in fact the dominant life form probably on Earth in the early stages. Is there any analogous organism that would actually expel oxygen or create and store oxygen as an oxidant on Earth that you know of?
That's where our oxygen comes from. Green plants, algae primarily in the oceans, take in the CO2 and produce the oxygen. And on Mars, there is an unbalance, which is what gave rise to the oxidant theory, the hydrogen peroxide theory. There's CO2 in predominance on Mars, and there should not be. As Chris pointed out, it ought to be precipitated out as carbonate, but somehow it's being recycled. So in order to recycle or explain how the CO2 remains in the Martian atmosphere, hydrogen peroxide was conceived of as then reacting with the CO2, with the carbonate, and reliberating CO2. But the other thing that could do that would be living organisms.
Okay, thank you. That's a very good example. I'm sorry, I didn't think of that.
Yeah, Dr. Levin, something I've wondered about for years, and maybe this isn't possible, but has anybody ever checked the Mars rocks that have fallen in the Antarctic for living organisms?
The first person to try that was Louis Pasteur. He got hold of the Orgueil meteorite, which fell near Paris, and he had just developed this technique for making hay infusions and brewing up cultures of organisms in there. So he actually split open a piece of that meteorite, scraped out some particles, put it in one of his hay infusions, got nothing. I don't know whether anyone has attempted that with the meteorites today, the SNCC meteorites. I do know they spent a lot of time analyzing for organic matter. Chris, do you know anything about that?
You can't separate out any extraterrestrial life because there's been too much terrestrial contamination, but Gil is correct that they have been able to isolate what they think is non-terrestrial organic matter, and hence they think that this is organic matter from Mars in the SNC meteorites. And interestingly enough, its carbon-13 to carbon-12 ratio is -20 per mil, which is the same ratio you find in living systems on Earth, but not in carbonate, which further makes the GCMS results mysterious.
The whole thing is very tantalizing, really is. Thank you very much.
Thank you, Gil.
Thanks.